Namaste, dear 10th standard students. Today we see your second physics experiment, determination of focal length of a convex lens by using the two methods, distance object method and another one is UV method. In this experiment, we need the following apparatus. First one is the light source and the second one is the biconvex lens. The third one is the lens stand and the fourth one is the screen and the last one is the meter scale. So these are all the things are essential to do the experiment. Here we have using two methods. One is the distance object method, another one is the UV method to determine the focal length of the convex lens. First we choose the distance object method. So set up the lens in lens stand and place a screen in a particular distance. Then adjust the screen. We can see a clear inverted image formed on the screen. Look at it. Once you get the clear image on the screen, then you measure the distance between the center of the lens stand and the beginning of the screen. So now what is the reading here? 10 centimeter. So the focal length of the biconvex lens is 10 centimeter from the distance object method. So the focal length of the biconvex lens is denoted by the letter small f. Then we find out 2f also. 2f means multiplying with f, 20 centimeter. Now this is the basic or fundamental value obtained from distance object method. Once you finish the distance object method, next we go to the UV method. So the distance between the light source and the lens is u. The distance between the lens and the screen is v. So that's why it is called as UV method. Children, look at the tabulation. This is the UV method. Here first we note down the size of the image. Where we get the diminished image, the value of 2f is greater than u. Already we know about the u value is the distance between light source and lens stand. So the distance is greater than 2f means we get the diminished image. And the value of u is equal to 2f means we get the same size image. And the value of 2f is less than u means we get the magnified image. Already we know the value of f and 2f from the distance object method. Now we proceed the UV method. See, here we set the value of u. The value of u is greater than 2f. What is the value of 2f? Already we know it's a 20 centimeter. So now we are chosen any readings greater than 20. So now I choose 24 centimeter. 24 centimeter is greater than 20 centimeter. So we choose 24 centimeter. The distance between the light source and the lens stand. Now we are adjusting the screen. Look at the screen. Now the image formed on the screen is a diminished image. Diminished means very small. So it's a diminished inverted image. Here you see the triangle is, and here you see the triangle in an inverted stage. You already know the value of u because you only set the value of u. Then you find out the value of v. Once you adjust the screen and you got the clear image, then you measure the distance between the lens stand and the screen. Here, what is the reading? Is the 15.5 is the exact reading, is the value of V. Then we set the value of U as 2F, which means U is equal to 2F, that is 20 centimeter. Once you arranged this, then we have move the screen and get the clear image. So now look at the image is the same size as it is in the light source. So the same image is formed. When we are arranging the value of U is equal to 2F. So this is the same size image. Now you have to measure the value of V. What is the V value here? It's a 20 centimeter. You have to note it down in your observation notebook. Finally, the U value is less than 2F. So 2F value already you know, it's a 20 centimeter. Now we choose 15 centimeter as U. So this is lower than the value of 2F. Now you can see the image formed on the screen. The image is the enlarged image. Now we measure the distance between the V. Once you get the clear image on the screen, then measure the V value, the distance between the screen and the lens stand. Now what is the value of V? Is 30.5. Once you finished these readings, then you calculate the value of F by using UV method. UV by U plus V. So you know the value of U and you know the value of V. So substitute these values from this formula and you get 5 set of readings. Now take the mean value of these 5 readings, that's also equal to the value of F. So the value of F from the distance object method is almost equal to the UV method. So the focal length of given convex lens is almost similar to 10 centimeter. Thank you children. All the very best.